Hello everyone, my name is Kiarra Rivera and today I'm going to talk about the microdiversity of the vagina microbiomes is associated with the preterm sperm. In this slide, I'm going to talk about the bottom line up front. One of the questions we ask is why is this research important? Preterm birth is a major global health issue contributing significantly to neonatal mortality and long-term complications. Understanding the risk factor, including the role of the vaginal microbiome, is crucial for developing early interventions. While the vaginal microbiome is known to influence pregnancy, its exact role is in preterm birth risk is not fully understood. This study investigated whether microdiversity with the microbiome can serve as a predictive factor. Now, the research question is, does variation in the vaginal microbiome impact the risk of preterm birth? If so, can we identify microbiome signatures that help predict preterm birth? A key contribution about this is this study provides evidence that specific bacterial diversity patterns correlate with preterm birth. The findings suggest that the vaginal microbiome could serve as an early risk assessment tool, potentially guiding future interventions to prevent preterm birth. A little bit about the background. The vaginal microbiome plays a critical role in pregnancy, with Lactobacillus species being dominant in healthy pregnancy. A stable microbiome is linked to better pregnancy outcomes, while microbial imbalance, known as dysbiosis, have been associated with complications. Previous research has shown that microbial imbalance can contribute to preterm birth. However, most studies focus on broad microbial shift at the species level. Few studies have investigated microdiversity, the genetic variations with bacteria species, which may have significant implications for pregnancy outcomes. Even with the same bacterial species, different strains can have vastly different effects. Some may be beneficial, while others could raise the risk of complications. This study dives deeper into strain level variation, helping us understand whether certain microbial signatures can predict preterm birth. The need and the urgency of preterm birth is one of the biggest challenges in maternal fetal health today. It can affect approximately 10% of pregnancies worldwide, meaning that every around 15 million babies are born too soon. This is not just about premature delivery. Preterm birth is leading cause of neonatal mortality, as I mentioned, and can lead to lifelong health complications, including respiratory issues, neurodevelopment disorders, and chronic diseases. Right now, our ability to predict and prevent preterm birth is limited. Current clinical methods such as measuring cervical leg and detecting inflammation marker are helpful but not always accurate. This is where the vaginal microbiome comes in. Scientists are beginning to uncover how microbial communities influence pregnancy outcomes. This study focused on microdiversity, the small genetic difference with bacteria species, to see if they could serve as early warning signals for preterm births. If we can identify key microbiome signatures linked to preterm birth, we might be able to develop new diagnostics tool and even microbiome-based therapy to help high-risk pregnancy, like future probiotics or antibiotics therapy. In the research focus, as we've seen, preterm birth is a major global health challenge, and our current clinical predictors are still not sufficient. This brings us to a key question. Could the vaginal microbiome provide new insight to preterm birth risk? This study aimed to address two main questions. Is there a measurable difference in vaginal microbiome diversity between term and preterm pregnancy? In other words, do women who experience preterm births have a different microbiome profile compared to those with full-term pregnancy? The second question is, do a specific microbiome strain correlate with preterm risk? This means, can we pinpoint specific bacteria species that are more common or protecting in preterm birth? By answering this question, the research could lead to a better predicting tools and potentially even microbiome target intervention for high-risk pregnancies. For the methodology overview, they investigate the association between the vaginal microbiome and preterm birth. They made a cohort study about 400 pregnant women. among them 80 experienced spontaneous preterm birth, and the 320 had a term birth. They collect vaginas and sample to multiple time points of the pregnancy, allowing research to track microbiome change over time. Most of these samples were collected through the first trimester onto delivery, but basically it was the first and the second trimester. They analyzed every patient for the period of 9 months. The techniques they used to analyze these samples were cysteine as rRNA gene sequencing. So basically, this technique identifies bacterial species by sequencing a conserved region of their genetic material, providing an overview of the microbial composition. The next one will be the metagenomic sequencing. Unlike cysteine as sequencing, this method captures all genetic material in a sample, allowing for a more detailed analysis of microbial diversity, function, and potential pathogenesis. The data analysis approach they use are alpha and beta diversity analysis. So this method compares microbiome diversity with an individual sample, alpha, and across different groups, beta, to assess the difference between terms and preterms. Other analysis approach was the machine learning models. They predict algorithms were used to identify microbiome signatures associated with preterm birth. And finally, the correlation analysis were applied to explore association between a specific bacterial species and pregnancy outcome. So, by integrating this technique, the study aimed to determine whether a specific microbiome shift could serve as early indicator of a spontaneous preterm birth risk, potentially paving the way for new diagnostic and therapeutic strategies. Now for the result, you will see figure 1 that illustrates the key difference in vaginal microbiome composition between preterm and term pregnancy. I put 4 points to talk about here. The first one is the higher microdiversity in spontaneous preterm birth cost compared to term pregnancy. So like I said, in preterm birth cases, we observe a higher level of microbial diversity. While diversity is often considered beneficial in some microbiomes, such as the gut, but in the vaginal microbiome, increasing diversity is actually associated with stability and higher risk of adverse outcome. The second bullet point is spontaneous pre-birth term associated with microbiomes. So if you see, the figure highlights our arrangement of opportunistic bacteria such as Gardnerella vaginalis and Uroplasma in preterm cases. These species are known for the ability to disrupt the protective vaginal environment, leading to inflammation and potential complications. In contrast, third pregnancy were predominantly associated with Lactobacillus cribarius and beneficial bacteria that help maintain a stable low pH environment in the vagina. This stability is thought to provide protection against infection and inflammation, reducing the likelihood of preterm birth. These findings supported this biopsy hypothesis, which suggests that an unstable, diverse microbiome characterized by increasing microbiome fluctuation may contribute to inflammation and preterm labor. Essentially, in cases of preterm birth, the vaginal microbiome appears to shift away from a protective lactobacillus-dominant state towards a more diversity and potentially harmful microbiome environment. Now let's move on to figure 2, which highlights the predictive microbiome signatures associated with preterm births. My first bullet point is distinct microbiome signatures predict preterm birth risk. One of the most exciting findings in this study is the identification of a specific microbiome signature that can help predict preterm birth risk. Rather than just looking at general microbiome diversity, this analysis focuses on individual bacteria, species, and their potential as biomarker for preterm birth. My second bullet point will be enrichment of Gardnerella vaginalis subtypes in preterm birth cases. As in the figure, Gardnerella vaginalis is significantly enriched in preterm cases. However, it's not just the presence of Gardnerella vaginalis that matters. is the specific subtypes that seem to play a critical role. Some strains of Gardnerella vaginalis are more strongly associated with inflammation and adverse pregnancy outcomes, making them potentially risk indicator for preterm birth. Other bacteria linked to higher preterm birth risk beyond Gardnerella vaginalis. We also see increased levels of uroplasma and Schnitzia in women who experience preterm birth. These bacteria are known to disrupt the vaginal microbiome and are often linked to inflammation, which can trigger premature labor. And the other is machine learning models enhance predictions accuracy. One of the most promising aspects of this research is the implication of machine learning models to predict preterm birth risk. By incorporating microbiome data, this model can identify patterns that might not be obvious through traditional analysis. This suggests that in the future, we could potentially use microbiome profiling as a clinical tool to assess a woman's risk of preterm birth early in pregnancy. To evaluate how well this model predict preterm birth, the study used a receiver operating characteristic, a ROC curve. This curve helps assess the model performed by plotting the true positivity rate, the sensitive, against the false positive, one specific. A model with perfect predicting ability will have a urea under the curve, AUC, of 1 point, while a model that performs no better than change will have a AUC of 0.5. And for the heat map that we can see, the microbiome composition in during pregnancy is dominated by Lactobacillus cripatus, which appear in high abundance, darker shades, while preterm birth cases show a more diverse microbiome composition with increased level of Gardnerella vaginalis, uroplasma, and Schnitzia. Another interesting observation is that spontaneous preterm birth cases, the microbiome composition fluctuates more across different time points. Whether terms pregnancy maintain a more stable bacterial community, this suggests that microbiome instability could be contributing factor to preterm birth. If we can identify this microbiome shift early in pregnancy, it might be possible to develop interventions to restore microbiome balance and reduce preterm birth risk. Now for this slide, result number 3, let's discuss the temporal changes in the vaginal microbiome through pregnancy and how they are related to preterm birth. So microbiome shift across pregnancy is a key indicator of preterm birth risk. One of the major findings in this study is that while the vaginal microbiome naturally shifts over the course of pregnancy, the result in preterm birth pregnancies exhibit these changes much earlier than third pregnancy. This suggests that the timing of microbiome shift could serve as an early warning sign to PTB. Higher abundance of risk-associated bacteria in the first and the second trimester. If you look at the data, we see that bacteria associated with PTB, such as Gardnerella vaginalis and uroplasma, were present in higher abundance during the first and the second trimester in pregnancy that later result in preterm birth. This is significant because it indicates that microbiome instability, the presence and potential harmful bacteria begin long before labor. Healthy pregnancy maintain a more stable lactobacillus-dominant microbiome. In contrast, term pregnancies were characterized by a stable lactobacillus-dominant microbiome through pregnancy. Lactobacillus cripatus, in particular, remain dominant in this pregnancy, suggesting a protecting role. This support previous research indicating that a stable and homologous vaginal microbiome is associated with lower inflammation and reduced preterm birth risk. Early shifts may serve as warning sign of preterm birth risk. So the fact that preterm birth associated microbiome change occur early in pregnancy raises an important clinical question. Can we use these early shifts to predict and potentially intervene in high-risk pregnancy? If clinicals could monitor microbiome changes in the first trimester, it might be possible to develop strategies such as probiotics, antibiotics, or other interventions to help stabilize the microbiome and potentially reduce the risk of preterm birth. An important key takeaway I want to mention is the study not just study the bacteria that are present, but also when they appear that matter for the pregnancy. Now I will be talking about the last set of results, the predictable microbiome signatures for a spontaneous pre-birth term that were identified in this study. Microbiome signatures for spontaneous preterm risk. One of the keys finding here is that specific microbiome strain can predict the risk of SPTV. Using advanced machine learning models, they were able to pinpoint crucial microbiome markers that are associated with the likelihood of a preterm birth. The other thing was the dual role of Lactobacillus species. Interestingly, some species of Lactobacillus were found to have a protective effect against SPTV, while others will link to a higher risk. So basically, the complexity of the microbiome, where certain strains might help protect against preterm birth, while others could help increase the risks about this. For identifying microbiome markers, they use a machine learning model that play a crucial role in identifying this key. By analyzing large data sets, the models were able to uncover patterns in the microbiome that correlated with spontaneous preterm birth, showcasing the power of these technologies in microbiome research. Something that you can see in the graphic is in the study they use antibiotics to target and eliminate a specific harmful bacteria, such as Gardnerella vaginalis and Mycoplasma, which have been linked to increase of SPTV. By reducing this bacteria, research were able to assess how their presence or absence impact the risk of preterm birth. Antibiotics were also employed to study how change in the vagina microbiome induced antibiotic treatment could influence the development of SPTV. This helped identify which bacteria are protected and which contribute to higher risk. Additionally, antibiotics were used to stimulate potential clinical intervention design as stabilizing the microbiome in pregnant women, helping to explore whether early antibiotic treatment could reduce the risk of preterm birth by restarting a balanced microbiome. Overall, antibiotics allow research to manipulate the microbiome, uncover microbiome markers linked to preterm birth, and explore ways to mitigate the risk through early interventions. Now I'm going to talk about the discussion. Here I made a resume way about the key findings, broader implications, and unanswered questions. I'm going to talk about the key findings. So the microdiversity in the vaginal microbiome is linked to spontaneous pre-birth term. This means that a more diverse microbiome could be a risk factor, while a more stable lactobacillus-dominant microbiome seems protective. Especially, we saw that certain bacteria like Lactobacillus crispatus appears to be protective, while others, such as Gardnerella vaginalis, are associated with higher risk. The broader implications, particularly for early screening, if we can identify microbiome signatures linked to preterm birth early in pregnancy, it could lead to more effective interventions that could help establish the microbiome and reduce the risk of SPTV. Despite this promising result, several important questions remain. One critical question is whether the microbiome causes preterm birth or if it's just a marker of underlying factors, and can we alter the microbiome in a way that prevents PTV, and if it's so, when is the critical window for intervention? Understanding the timing of this shift is crucial for developing effectiveness clinical strategies. A key strength that I found is the use of machine learning models to analyze large database which enable the precise identification of microbiome signature linked to spontaneous pre-birth term. However, limitations including the relatively small sample size and potential confounding factor that could affect the results. These findings have significant clinical implications, particularly in the potential of personalized medicine. By identifying protective and risk-associated bacteria, interventions like probiotic or antibiotic could be used selectively to stabilize the microbiome and reduce preterm birth rates. This research also contributes to a broader field of microbiome science, suggesting that the vaginal microbiome is just one aspect of a large microbiome ecosystem, and that other microbiomes, such as those in the gut, may also play roles in pregnancy outcomes. For the conclusion of this presentation, has addressed a critical topic: the role of vaginal microbiome in spontaneous preterm birth. Through the talk, we've seen that the vaginal microbiome is not simply about the presence or absence of certain bacteria. Rather, microbiome diversity and especially strain level difference play a significant role in influencing the risk of preterm birth. One of the key finds for the research is that certain lactobacillus species are associated with a lower risk of preterm birth, while others, such as Gardnerella vaginalis, are linked to a higher risk. These finds open the possibility of using the microbiome as a biomarker to predict preterm birth risk, allowing for early and more personalized interventions. Furthermore, the use of machine learning models to identify these microbiome patterns has shown the immense potential of technology in microbiome research. These models allow for more precise identification of key bacteria that could predict spontaneous preterm birth risk, something that would be difficult to achieve with traditional methods. However, there are still several unanswered questions that need to be addressed in future study. For example, if the microbiome the direct cause of the preterm birth, or is just merely a marker of underlying factor. Additionally, we need to understand if we can modify the microbiome in ways that actually prevent preterm birth, and if so, what is the critical window for intervention. Looking ahead, validating this result in large cohorts is crucial to confirm the findings and determine how they can be applied clinically. It is also important to explore therapeutic strategies that could possibly influence the microbiome. These interventions could provide new ways to manage preterm birth risk and improve outcomes for both mother and baby. In summary, while research on the vaginal microbiome and its relationship with preterm birth is progressing rapidly, there is still much to learn. However, these events represent an important step toward developing more precise diagnostic methods and intervention strategies that could change the way we treat and prevent preterm births. For my questions, the first one is: how do we distinguish between causation and correlation in microbiome studies? So I choose this question because it's one of the fundamental challenges in the microbiome research. Microbiomes are highly complex and it's difficult to determine whether microbiome shifts are a direct cause of preterm birth or if they are simply associated with it. Understanding this distinction is crucial for developing effectiveness interventions. I'm curious about how future research can employ more sophisticated techniques, such as causal inference models, to untangle this relationship. The second question would be: what are potential clinical applications for these finds? So these questions arise from my interest in translating research into real-world solutions. If we can reliably predict preterm birth risk through microbiome markers, it could lead to new diagnostic tools and preventing strategies, such as probiotics or antibiotics. I'm curious about how quickly we can move from research to clinical implementation and how these innovations could impact healthcare systems globally. My third question is how my lifestyle or diet influence vaginal microbiome diversity. This question came from the growing body of research linking diet and lifestyle to the microbiome. Since many factors like diet, stress, and exercise can impact microbiome community, I want to explore how this factor might influence vaginal microbiome diversity and, by extension, preterm birth risk. From close experience, I have friends that pass from stress and different diet through their pregnancy, so this will be curious to search. And it's fascinating to think about how small changes in daily habits might improve microbiome health and reduce preterm birth risk. My fourth question will be, could target microbiome intervention reduce preterm birth risk? As I delved into the potential of microbiome-based treatment, I became curious about the possibility of intervention or even microbiome transplant. Could these strategies help reduce preterm risk by restoring a healthy microbiome balance? This question ties directly to the real-world application of microbiome research and the exciting potential for target therapy. My number 5 question, my last one, will be, what are the ethical considerations of microbiome-based therapy during pregnancy? I chose this question because as we develop microbiome-based therapy, we must be mindful of the ethical implications, especially in vulnerable populations like pregnant women. There are questions about patient consent, the side effect of intervention, and the accessibility of these treatments. I'm curious about how we can ensure these therapies are safe, well-regulated, and equitatively, while still being effectiveness to this pregnancy. For summarize, these questions highlight both the excitement and challenge of microbiome research, especially when considering its potential to transform preterm birth, prevention, and healthcare. Each of these questions open the door to future exploration, and I'm excited to see how the field evolves. Tell me what do you think about this?